Happy day students. Today we are going to learn about parallel axis theorem. So what is meant by parallel axis theorem? Before going to learn about parallel axis theorem, let's see the last topic what we had discussed. Moment of inertia. What is the formula for moment of inertia? Mass into distance, perpendicular distance, square of the distance. Moment of inertia. What is the moment of gyration? I equal to m k square, where k is called as moment of gyration or radius of gyration. Okay, radius of gyration k equal to root over I by m. Okay, this is what we discussed in last class, moment of inertia and radius of gyration. Now we are going to discuss about parallel axis theorem. From the parallel axis theorem we can find the moment of inertia at any point. Okay, so we'll see the sums later, examples later. Let's see what is the parallel axis theorem. Okay, right. So the statement as given here. So parallel axis theorem, the moment of inertia of a rigid body about any axis, moment of inertia of a rigid body about any axis is equal to the sum of moment of inertia, sum of moment of inertia about a parallel axis passing through its center of mass. That means center of mass inertia and center of mass and product of product of the mass of the body and square of the distance d, square of the distance, perpendicular distance between the two parallel axes. So let's prove this. Okay, so let's consider any shape, one rigid body. This is the shape. Okay, so in this shape let's consider here is the axis of rotation, center of mass, where the center of mass at this point, center of mass is there. Let's consider c. Okay, now if this is the center of mass IC, moment of inertia or around at the center of mass or passing through the center of mass, moment of inertia of the axis which is passing through the center of mass. Okay, now I want to find the moment of inertia at this point. So this is the moment of inertia I. Okay, let's consider this is a parallel axis, these two are parallel. Okay, now let's consider this point is some a. Okay, for this line there is the center one. Now I want to find a center of mass or moment of inertia at this point, moment of inertia. So let's consider at this point the total mass is m. At this point what will be the mass? Here the mass is considered as delta m. Okay, so from this it is at a distance. Let's consider this point is p. Okay, this point is a, c, and that point is p. Now from there to here this point will be c. Now from this can I form one triangle? Right angle triangle? Right angle triangle is formed. These two are perpendicular. Let's consider this point is some that p, no, so let it treat it as q. Okay, so cpq1 triangle, a to c is another one, a to c. So let's consider a to c, the distance, perpendicular distance. Here I consider as d. So this perpendicular distance is d. Okay, so I equal to ic plus md square. We are about to solve that. Clear? Right. So here apq is a one triangle, cpq is one triangle, right? So what is the moment of inertia? What is the moment of inertia from this point to this point? So what is the distance ap from this point? Cp. So from moment of inertia at point A, this is the moment of inertia that I need, I equal to, so delta m for this point, delta m. What is the distance from here to here? It is o to p. This is the distance, right? Op square, op square. Why it is? What is the formula for moment of inertia? I equal to m r square. M is here, delta m. R is nothing but distance. That is what distance? ap. Sorry, it is ap, ap square. Okay, next, around at the center of mass ic, ic equal to delta m from here to here. What is the distance? cp. So cp whole square. So I equal to delta m ap square, ic equal to delta m cp square. Okay, got it? So now here this is for how many particles? For only one, this one particle. Like this there are many particles are there, so each particles will be added. So this will be written as I equal to summation delta m ap square, ic equal to summation delta m cp square. Okay, clear? So if you are getting confused now, you can take this as O. Okay, then it will be OP square. Okay, now clear? So that will be OP square, as it's an origin, then will be taken as OP square. Okay, clear? Right. Next, here at this point, this one triangle, no? Clear? It's one triangle, right? And similarly OPQ. So there is a triangle OPQ. So from this triangle, what will be written? Hypotenuse square equal to side square plus side square. What is the hypotenuse square? OP square equal to this side. What is this side? OQ. OQ square plus PQ square. OQ square plus PQ square. From this, and next, here there is one more triangle. What is that? CPQ. From the triangle CPQ, what you will get? CP square equal to CQ square plus PQ square. CP square, CQ square plus PQ square. So from this, OP square equal to OQ. OQ means this total distance now, that is OC plus CQ. So that means OC square plus CQ square plus 2 OC into CQ. A plus B whole square formula, nothing. Okay, plus PQ square. PQ square plus CQ square. PQ square plus CQ square is nothing but CP square. So OP square equal to OC square plus CP square plus 2 OC. OC is nothing but distance D. Okay, this distance. So D CQ, DCQ, that's all. Okay. So this is the equation we got. OC square plus CP square. OC square plus CP square we don't know. Okay. So from this, what we are going to write it is OP square. Let me write it in OP square equal to OC square, OC square, OC square plus CP square plus 2D CQ, CP square plus 2D CQ. 2D CQ, right? So from this, I am going to multiply delta m on both the sides, fully multiply. So delta m OP square equal to delta m OC square plus delta m CP square plus 2D delta m CQ. Okay. So from this is for only one particle. Like that many particles are there, no? So we have to do the summation. So delta m OP square equal to summation delta m OC square plus summation delta m CP square plus summation 2D delta m CQ. Okay. So from this, delta m OP square is nothing but what? Delta m OP square is nothing but I. CP square is nothing but IC. So delta m OP square is nothing but I equal to IC plus what? Delta m CP square. CP square is nothing but what here? 2 OC. OC square means what? OC means R square, right? Got it? So OC is nothing but R. Just replace that. OC is nothing but R square. So delta m OC is nothing but R square plus this delta m CP square. Delta m CP square is IC. Delta m CP square is IC. Okay, so it is IC plus sigma 2D delta m CQ. So this will be written as I equal to IC plus this total will be written as sigma delta m will be written as m R square. Here what we will consider? D, no? So it will be D. M D square plus 2 I equal to IC plus m D square plus summation 2D delta m CQ. If this total term comes to 0, then I equal to IC plus md square. This is the parallax theorem. Why this total term will be 0? At that point, at point what? At the point of P. this distance, that means in this axis, the moment of rotation at that point, the sum of torques, sum of sum of all the torques acting at that point is 0. So sum of all the torques acting at that point is 0, then remaining I equal to IC plus md square. So here what is meant by I? I is nothing but moment of inertia about an axis which is parallel to the axis, okay, through the center of mass, axis. Okay, this moment of inertia will be parallel to the axis. So now what about IC? IC is nothing but center of mass. So okay, moment of inertia about an axis which is passing through center of mass. This is moment of inertia which is parallel to the axis of center of mass. So I and IC. D is the distance of perpendicular distance between these two parallel axes, perpendicular distance. Okay.